Hello students, in previous lecture we have seen one function and onto functions. Now in this lecture we are going to see bijective function. Now let's see definition. So bijective function, bijection. So what is meant by bijection? So f from x to y is said to be bijection if f is 1 and onto, means function f is both 1 and onto function, then we say that the function is bijective. So 1 function means injective function and onto function means surjective function. Now let's see the definition of function f from set x to y. So x is domain, y is codomain, which is both 1 and onto is called bijection. So bijection means the function which is 1 and onto. So 1 means which is injective function and onto means surjective function. Now let's see the example. Let f from r to r defined by function f of x is equal to twice x plus 3. So here function twice x plus 3, then f is 1 and onto function. Because so in previous lecture we have shown that f of x is equal to twice x plus 3 is 1 and onto. So hence we say that f is on bijection. F is bijection. Next example. Now let f from r to r defined by f of x is equal to x plus p is bijection. Where here is any condition on a, so a is always non-zero. So to prove this is bijection means what, function f of x is both 1 and onto. Now here what is the function f is from r to r and function f of x is ax plus b. Now first to show function is 1. Now I will take two values from real number r domain, then we can show the function on 1 in by two ways. If both functions are equal then their values are equal, and other ways if values are different then functions always different. So first to this, if f of x is equal to f of y, then what is f of x? Ax plus b is equal to ax plus b. So b get cancelled, so remaining ax is equal to ay. So here is function of y, so ay plus b. So here ay, so a is not equal to 0 we have given, then divide both sides by a, so we get x is equal to y. Means what, here f of x is equal to f of y, then finally I get x is equal to y, means f is 1. Now to show onto function, f is onto. So for onto function, what is the definition? Now for all y belongs to y, there always exists x belongs to x, such that how to exist, y is equal to f of x. So y is equal to, what is f of x? F of x is ax plus b. Now solve this equation for value of x. So I get, so b is outside, so ax is equal to y minus b, so divide both sides by a, so finally I get x is equal to y minus b upon a. Here a does not, which is not equal to 0. So here we have taken y belongs to what, codomain, which is from real number r, and x belongs to x, which is again from R. So what we have given, so y belongs to R, then y minus b upon a again belongs to real number R. Therefore x is equal to y minus b upon a, which is from real number R, which is domain in R. Therefore this is R, this belongs to R, means what, f is onto function. F is onto function. Here f is both 1 1 and onto, therefore f is bijection. Therefore f is bijection. Hence this is the solution of the example. Let's see another example. Consider f from close 0 1 to close AB, and here A is strictly less than B, defined as f of x is equal to bx plus a into 1 minus x. They show that f is a bijection. Now here we have to show f is bijection, means what, we have to show that function f of x is 1 1 and onto both. So solution, to show, we will show f is both 1 1 and onto. So 1 1 and onto means what, injective and surjective. So first 1 1. Now for, so 1 1 case, now for I will take x y belongs to what, closed interval 0 1. Then if f of x is equal to f of y, so f of x is this function, so I will write bx plus a into 1 minus x is equal to, so I will replace x by y, then I get by plus a into 1 minus y. So here bx plus a minus ax is equal to by plus a minus ay. So I will take x as a common, so b minus a into x plus a is equal to b minus a, take y as a common, into y plus a. So y a cancel, so remaining b minus a into x is equal to b minus a into y. Here a is strictly less than b, means what, b minus a which is greater than 0, which is not equal to 0. So here b minus a not equal to 0, so we can divide both side by b minus a, so you will get x is equal to y. So here f of x is equal to f of y, and finally I get x is equal to y, means what, f is 1 1 function. Right, now to show f is onto, so how to show, now for all y belongs to codomain, there exists x belongs to 0 1 such that y is equal to f of x, means to find value of x. So here for all y belongs to y means what, here closed AB, then there exists x belongs to what, 0 to 1 such that, how to exist, y is equal to f of x, and solve this for value of x. So y is equal to, what is f of x, f of x is bx plus a into 1 minus x. Now we can solve it by x, so y is equal to bx plus a minus x. Now take x as a common between these two, so I get y is equal to b minus a into x plus a. So a replace on other side, so y I get b minus a into x is equal to y minus a. So finally I get, so here b minus a is non-zero, here we have seen, so we will divide both side by b minus a. So I get x is equal to y minus a upon b minus a, which belongs to closed interval 0 to 1. Therefore, we say that function is onto. Here y minus a upon b minus a belongs to 0 to 1. Let's see how it belongs to. Now here what we have given, y belongs to 0 to a to b. So here a less than equal to y less than equal to b, and we have to find y minus a upon b minus a. Now we will subtract both in this equation by a, then what will I get? A minus a less than equal to y minus a less than equal to b minus a. So which implies that a minus a 0 less than equal to y minus a less than equal to b minus a. Divide throughout by b minus a, then what will we get? So divide by b minus a, then what will we get? 0 upon b minus means what? 0 less than equal to y minus a upon b minus a less than equal to b minus a means b minus a upon b minus a 1 means what we get here? Y minus a upon b minus a which lies between 0 to 1 means x is equal to y minus a upon b minus a belongs to 0 to 1 means what we say that therefore f is onto function. F is onto function. Here we have seen f is 1 function and f is onto function. Then we say that therefore f is both 1 and onto. F is 1 and onto. Therefore f is bijection. Therefore f is bijection. Hence solution. So this is the proof. Next example. Find a 1 map from natural n cross n to natural number and 1 map from natural number to n cross n. Means here what is the function f from natural n cross n to n means domain of the function is nothing but order pair and codomain of the function is nothing but singleton natural number. So natural number, and here the second function natural number to n cross n means domain of function natural number and codomain of the function is nothing but order pair. So we will define the function which is 1 So 1 means what? F of x is equal to f of y, then finally x is equal to y. So let's define, consider the map which is 1 from n cross n to natural number. As so what is the n cross n means our domain is order pair and codomain is natural number, means we have to define function f of, here we have to domain of the function in between. So this is the order pair value, means n cross n I will take order pair which is m and n, and output of the value is nothing but single natural number. So I will define this f of mn, I like this 2 raised to m into 3 raised to n. So mn belongs to natural number, then 2 raised to m into 3 raised to n which is again natural number. Here is multiplication. So we have to show this is 1 then this map is 1 then this map is 1 So to show this is 1 now we have to show this by using two ways. If if f of x is equal to f of y, then finally show that x is equal to y, or in other ways, if x not equal to y, then show that f of x not equal to f of y. Now we will show this. Now let's suppose I have two order pairs. Suppose these two order pairs are not equal, means here m1 n1 not equal to m2 n2. So this order pair not equal means what? What we say that m1 not equal to m2 and n1 not equal to n2. That implies m1 not equal to m2 or n1 not equal to n2. So m1 not equal to m2, then I will write it 2 raised to m1 not equal to 2 raised to m2, or here n1, so n means what? 3 raised to n1 not equal to 3 raised to n2. So I will multiply component wise. So what will I get? Here 2 raised to m1 into 3 raised to n1 not equal to 2 raised to m1 into 3 raised to n2. Sorry, this is here m2 and n2. So this equation multiplied by component wise means so 2 raised to m left side multiplication 2 raised to m1 into 3 raised to n1 not equal to 2 raised to m1 into 3 raised to n2. So this is 2 raised to m1 into 3 raised to n1 means what? This is function f of m1 n1, which is not equal to f of, this is f of m2 n2, f of m2 n2. So here the two values are not equal, therefore functions are not equal. Then we say that therefore f is 1 1. Now next, so we have defined first function. Now to define second function, so which is, so here we have defined f from natural number to n cross n means what? The function domain is natural number and codomain is order pair. So I will define as, which is defined as f of n is equal to n comma n. So this is the domain, so single natural number, and this is order pair, right? So I will not write it as m and n because our domain is natural number. So domain is single, so I will write here n comma n. So we have to show that this is 1 1, then this map is 1 1, then this map is 1 1. So let's see how it happens. So let if n1 n1 is equal to n2 n2, n1 n1 is equal to n2 n2, which implies that what we say that f of n1 is equal to f of n2 means what? If two values are equal, then we say that functions are equal, therefore f is 1 1. So this is the map defined from natural n cross n2 natural number by f of mn is equal to 2 raised to m 3 raised to n, and n2 n cross n, which is f of n is equal to n comma n. Now next we will see how to understand a function graphically, which is 1 1 or on 2. So let's see understanding function of graphically. Understanding of function graphically. How to understand the function 1 1 on 2 or bijection. So if f from, so first f from r to r is 1 1 if and only if what? Every horizontal line intersects the graph f at most once, then we say that function is 1 1. f from real number to real number is 1 1 if and only if every horizontal line intersects the graph f at most once. Means suppose I have the function y is equal to x. This is the function. What is the graph? So graph of the function is like this. So this is y is equal to x. So what is our domain? Our domain is, this is the domain. So this is the domain is real number r, and this is the codomain is real number r. So this is x axis, this is y axis. So what the first case says, if f from r to r, so what is r? This is the domain, and r is, this is codomain, is 1 1 if and only if every horizontal line intersects the graph f at most once means what? If I draw single horizontal line which is parallel to x axis, if I draw horizontal line which is parallel to x axis, then it cuts graph at most once, then we say that function is 1 1. Here if I draw the horizontal line parallel to x axis, then it cuts the graph at most 1 point, means in R codomain I have to draw single line, then which cuts the graph single point at most 1 point. So most once means more than 1 point cuts the graph, then we say that function is not 1 1, right? So here y is equal to x, every single horizontal line cuts the graph at most 1 point, then we say that the function is 1 1 function. Suppose if I will take graph y is equal to x square, then what is the what will be the graph of the function? So the graph of the function is like this, and here what? Here the domain of the function is real number, and here codomain of the function again real number. And here if every horizontal line means every means what? I have to draw every horizontal line from codomain. Here is R, from every R, here is y axis, here codomain is real number R. In every codomain I have to draw every horizontal line, and horizontal line cuts the graph at most once. But here if I draw the line horizontal line here, but there is no graph, so here there is no intersection between graph. Now if I draw horizontal line here, then it cuts the graph in 2 points, then this function y is equal to x square from R to R is not 1 1 function, right? Means what? If this graph is like this, only this type, if you have this graph is like this type, and then we have draw the horizontal line, then this cuts single points, right? So this point means what? If you have given codomain is positive real number, then we say that function is y is equal to x square is what? Sorry, here domain is positive real number, then we say that the function is like this. So the y is equal to x square from R plus to R defined by like this. So if I draw the horizontal line, then here graph cuts single point, then we say that y is equal to x square is 1 1 function. But here R to R, so what is the graph like this? So here horizontal line cuts between 2 points, therefore the function y is equal to x square is not 1 1 function. Now second, f from R to R is onto if and only if every horizontal line intersects graph, every horizontal line f from real number R to R is onto if and only if every horizontal line intersects the graph of f at least once. F from R to R is onto if and only if every horizontal line intersects the graph of f at least once. At least once means what? More than one. Graph should cut more than 1 point, means at least one. So if we have now we have seen the function f of m is equal to m square, f from what? R to R. Here domain is R and codomain is R, which is not onto. We have seen in previous example, right? So what is the graph of this function? Here graph of this function like this. Here domain of the function is R and codomain of the function is again R. Here if I draw horizontal line, here if I take 2, then which this line does not cross this graph, right? Means the graph or this line does not cross this graph, means what, line intersects the graph, means if function is on to if and only if what, f intersects the graph at least once. Here there is no intersection between graph and points, so f of m is equal to m square is not onto function, means what, 2 has no pre-image in this function. So this is the geometrical or graphical meaning for on and onto function. Now third case, f from r to r is both 1 and onto if every horizontal line intersects the graph of f exactly once, means f from r to r is 1 and on 2 if every horizontal line intersects the graph of f exactly once. So this is, again I will take example, f of m is equal to m square. Then we see that both the function is 1 and on 2, means what, bijection. Then every horizontal line intersects the graph exactly once. Now if I take example f of m is equal to m square, f from r to r, then this function is not 1 and on 2, because so this is 1 but so here if I draw the line here, then which does not intersect the graph, therefore here what we say here, third case, if every horizontal line intersects the graph of f exactly once, then this is 1 and on 2, which is means by bijection. But here if I draw this line here, then there is no intersection between the graph and lines. So if I take example again, y is equal to x, then I can draw the lines, see every line, so the graph and line intersects exactly one point, so here like this. Therefore y is equal to x from r to r is a 1 and onto function. Now in next lecture we will see composition of function and inverse of function. Thank you.